Right, the BGP attribute, we have seen the attribute list. If you want, I can remind you once. This is what we saw. This is the page 20. This is the attribute list. Now we are going to do this lab. We can do this like by setting weight on a router, local preference on a router. We can do this on a per destination basis or for the entire destination, for all destinations. Per destination we'll use route map. For all destinations, no need of route map. So to learn about route map, I would like you to see another presentation. Remember this. We have an expectation, we have a policy that the incoming 10% should be via the upper path, inbound. Inbound of what? Traffic. Traffic is coming from somewhere outside. It's not update, traffic. We are talking about traffic. 60% of outbound should be from this. 20% of outbound should be from this. And 75% should be via this, inbound. To achieve this, definitely we need a route map because this is policy based. And not for all traffic. See? Only 60% of traffic should go out this way, which means you have some destinations to which 60% of traffic is generated. I need to identify that, put it in the route map and do it. We did this, this example. We did this for your remembrance, for you to recall. I'm just stopping here for a minute. Go through this. Try to recall. We did this. So let's do our scenario. The first is, I want to see these two routes on these three routers. I want to see these two routes, two destinations on these three routers. For that, let me first go to router 1. Show IP BGP. I do see it. I'm interested in only this and this. Show IP route BGP. Yes. Now both this and this goes via router 6. This router 1 uses router 6 to go. Why? Why it's not going via router 2? Because router 2 is too far. 1, 2, 3 hops. Whereas when it goes via router 6, it is just 1, 2 hop. This won't be considered as a hop. Why? It is within the autonomous system. BGP is AS by AS routing protocol. For BGP, router is not one hop. One autonomous system is one hop. Even if I have 100 routers here, it will go like this only. Because within an autonomous system, the hop counts are not calculated. BGP is autonomous system by autonomous system routing protocol. Now what's our aim? Our aim is to send the packets to this destination, only 155 destination, via this way, and only on this router, for which we need to use route map with wait. So let's go. What I'm saying is this via, it should be 125.12.02, which is router 2's address. And I don't want this to be on router 7 and 6. I want it to be only on router 1. Let's move to router 1 now. Before that, I would like to show you router 7 also. Show IP route BGP. Router 7 is still going via router 6. I do not want this to be changed. Router 7 should always go via router 6, and router 6 should go always via router 4. For 55 and 155, it is always going on router 4. So only on router 1 I want this path, like 155, it should go via router 2. How to achieve that? First, write an access list. Show IP BGP. You see the mask here, that's very important. 32 masks. So your access list also should be 32. Access list, any number, permit, host. When I say host, it means 32-bit. If you don't say host, then what I should do? You should write this 0000, this wildcard mask. If you don't want to write this wildcard mask, then put the host command. When I say host, it is 32-bit address. Alright. Now access list is written. Next, route map. Use the word permit, route map, give a name. I'm going to say name as 155 on top. Some name which you will remember when you see this, you will remember what we did to it. Now I'm going to match the access list. Match IP address, that's the command, and you see we can put a standard access list. So I'm going to use the number 10. If match happens, what I want to do is set wait. Wait by default is 0. I'm going to say 20. Exit. Please pay attention. This route map I'll be binding on this router. How? I'll say when you receive update from router 2. From means what? Inbound. When you receive update from router 2, look for that 155 network. If that matches, what you need to do, you need to set wait 20. So for 155 network, it is going to set wait 20. What about the other networks? Other networks, I want to just receive as it is without any attribute change. For that, for other networks which did not match this access list, I need to create another same route map but another sequence. I'll say 11. See, earlier I did not say any sequence. So by default it would have given 10. Now I am saying next, if this didn't match, you need to use this 11. For 11, I'm not going to write anything, which means just allow it same as you receive it. So whoever did not match, whatever the destination that doesn't match here, will be simply allowed, permitted as it is. Let me show you the route map. Show route map. You see this permit and sequence 10, I did not write. It comes automatically. When access list 10 is matched, wait is set 20. And this one I gave 11. You saw me giving that. This permit is dynamically given. And nothing is matched, nothing is sent, which means all the rest should be simply accepted. Now, I have applied this nowhere. Let us go and apply this. Router BGP 1000. Neighbor 125. Listen, update is coming inbound. 125.12.0.2. I use the route map. This one. Inbound. Update is coming from this neighbor inbound. When it comes, do this according to the route map. Show IP BGP now you can see, oh, no impact so far. Still 155 is going via router 6. You need to wait long, otherwise clear IP BGP star. So You see, the weight is attached. And now earlier this greater than symbol was here, pointing towards router 6 as a next hop. But now from here it is jumped to here, points towards the eBGP, even though it's a long route, because wait comes before AS path. It is now going via eBGP. Let's check the routing table. Show IP route BGP. You can see for 55 destination, we got this. See, in our example, just 2 networks. In the real world, you may have 200 networks, in which for 100 destination you need to write an access list and send it via upper path, the other 100 via the below path. Now this will not impact router 7. Go to router 7. Router 7 will still go via this path like earlier. Let's check. See? No change. Why? We have not set local preference. We have set only the weight. Weight is local to that router where you configure. Only R1 will have the impact, not R7 or R6. Show IP BGP. Here it is still going via R6. No impact on weight, you see. It's the same condition if you check on router 6. Earlier it was going via router 4. Even now it is going via router 4. Now, if you wish to send all the packets from all the IBGP routers, if you want to send all packets to 155 via the upper path from every router in your autonomous system, instead of wait, I should use local preference. Simple, I'll show you how to do it. I'll simply go and edit it. I'll just go to the route map which I just created. Route map sequence 10, and the access list is already written. This is the access list. I do not want to disturb. I'll simply remove it and I'll set local preference. The default is 100. I'll say 150. And now clear IP BGP star. Now you are going to see not only router 1, even router 7 and 6 going via the upper path. Show IP BGP. You can see that for 155 network it is going via router 2, whereas for the 55 network it is still going via router 6, because for 155 you got local preference set. Check the routing table. Show IP route BGP. You see 155 is going via router 2 and 55 is going via router 6. Not only on router 1, this time you will see it on 7 also. Earlier, for 155, the local preference was 100 when it was received from router 1, but now it is 150 when it is received from router 1. So it prefers to go via router 1. Show IP route BGP. You see, for 155 it prefers to go via router 1, means upper path, but for 55 it goes via router 6. Next is router 6. Earlier it was going via this way, but now it goes via this BGP router 2. Yeah. So if you want to impact the whole autonomous system, use local preference. Only on one router, use wait. So the only difference is between the wait and local preference configuration. Everything remains the same except this. You understood wait earlier. You understood that I wrote an access list, I called the access list, I set wait instead of local preference, and then I went to the neighbor statement and I said whenever you receive update from this neighbor in, you need to add wait. Now instead of wait I am saying add local preference. Ante. Let's check. Show RAN section router BGP. You can see here the same route map which we were using for wait still there. Yeah.
One more question about. So local preference is always configured with route map only, or it can be done directly under BGP?
If you are doing it directly under BGP, it is going to impact all the destinations. I'll do that once. You see.
Okay.
I'll remove this.
So Aaron, while you did on local preference, you have also wait, no, right?
No, I removed wait and put the local preference.
Okay, got it.
Now, I removed this route map which I attached to BGP neighbor. And also I will remove the route map for you. That should not be an hindrance. So no route map, no neighbor with route map. Clear IPBGP star soft. Show IPBGP. Now this will go as usual. You see, no local preference is set, no wait is set. For 155 it is going via router 6. For 55 also it is going via router 6. Now, Pradeep's question is there any way that we can use this local preference and wait without using a route map? See, the reason for me using route map is I have a policy where the path selection is per destination basis. If I want only for this destination, then I need to definitely use a route map. I need to match with an access list and then call it under the route map and do it. No other go. But if you don't have that requirement, if you say for all destinations, so in our case for both this and this, I want all these routers to go this way, even though it's a long route. Then I need to simply go to this router like this. Wait, right now, show IP route BGP. They are going via below path 6.6.6.6. Not only this router, even router 7. See, 6.6.6.6. Focus only on 55 network and 155 network. It's going via 6.6.6. And what about router 6? This is also going via below path 4 this way only. So by default all of them are going this way. That's what I showed you. But our aim is to remove this and make it as this on all the routers. Because it is all the routers, you don't need wait. You need to set local preference. So what I do is I choose router 1. I go to router 1 and say, hey, your local preference is 110. When I do that, when R6 is saying local preference 100, for the same destination, when R1 says 110, then this 110 attribute will be advertised to everyone. So everyone will now decide to go via router 1 because router 1 has got higher preference, local preference. See how to do that. Go to router 1. Router BGP 1000. BGP default local preference 110. That's all. This will impact all the routers and in the autonomous system to reach all destinations. Clear IP BGP stars off. And now let me show you the routing table. Show IP BGP first. You can see now for 55 it started going via router 2 directly. Why it is not showing any local preference? Because it is eBGP. But it is achieved. What we want is achieved. In router 7 you can see this local preference set. Show not on router 6. In the router 6 also you can see show IP BGP. Look at this. 110 for 55. It's going via router 2 now. Even though it's a long path. We set on router 1, the impact is seen not only on router 1, on every router inside this 1000 autonomous system where router 1 resides. 55 network, it's not going via router 4 now. Earlier it was going via this way, now it is going via the upper part. You can check that in the routing table also. Show IP BGP. Show IP route BGP. Upper part. The reason is this number. Now this is on router 6, right? Let's check it on router 1. I think 1 we have checked. Show earlier show IP route BGP. Earlier it was going via router 6 and now it goes via upper path. So When do we use globally? This is the scenario. I just demonstrated it. The command is show run section router BGP. Globally, you have to say under the router mode. Under the router mode, you need to say BGP default. Here it is. How can we do that for weight? Weight is locally significant to that router. How can I do this using weight? Globally, how can I do using weight? We use route map, but without route map, how can I use? You can use like this: router BGP 1000. Remove this local preference. But if you have local preference also, that won't be a problem. Why? First it will check weight, then only it will go for local preference. Now, listen. I removed local preference, so all other routers will go via the bottom path. Only R1 should go via the upper path. For that I use neighbor command. Neighbor, I say neighbor, whenever you receive update from 125.12.0.2, which is router 2, use the weight. Whatever this neighbor gives, more weightage. The default is 0. I am giving 80. Here IPBGP starts off. Show IPBGP. You can look at this. So for all networks learned from router 2, weightage high 80 is assigned. As a result, it goes via the upper path, not only in router 1, only in router 1, not in 7. Earlier 7 was going via the upper path, now it should go via the below path. Earlier now it should go via the below path because I removed the route map. See, 55 it goes via the below path. Check the routing table, show IP route BGP. Earlier it was going via router 1 upper path. Earlier router 6 was going via the upper path, but now it goes via the below path. Router 4. Pradeep, did I answer your question?
Yeah, it's clear. And one more question. In the earlier output, it was showing weight 32768, right? Is that,
what is that?
In the earlier output, it was showing weight value as 32768.
No,
right?
no, listen, no. You are not focusing on the network that we are discussing. You are not focusing on that network that we are discussing. Listen, show IP BGP. This weight 32768 is not for 55 network and 155. I asked you to focus only on these destinations. These destinations. Wait. Listen.
Okay.
For that destination, there was no 32768. Okay?
Yeah, right.
Okay. Now, whenever your network under BGP that you advertise is directly connected to the same router, your next stop will be 00, meaning this has to be preferred because it is directly connected. So BGP in Cisco automatically assigns this weight so that If there is 7777 network coming from outside, that outside should not be preferred. This is dynamic and only for this network. So for directly connected network, the next stop will be 000. If the next stop is 000, weight will be 32768. Right. I